Welcome everyone. Thank you for joining us for today's webinar. My name is Agata Walker and I'm the Marketing Manager here at InVMA. I'm here to introduce you to our keynote speakers. John Hill, our Chief Operating Officer, will start with introducing InVMA and this series of webinars. Then we have Andy Gailey, the Founding Director of Uptime Consultant Ltd. A mechanical production engineer by trade, he spent his formative years in turbine manufacture, prototype machining, and motorsport before going on to work for PepsiCo International in the snack food sector for over 20 years. Between 2006 and 2015, Andy developed, tested, and run the condition monitoring and lubrication program for the largest snack food plant in Europe, saving six-figure sums annually for the business. If it rotates and breaks, the Andy is interested in mitigating or stopping that pain. And finally, Peter Livaudais from Senseye, responsible for managing relationships with key customers in France and finding new opportunities across the region with large-scale organizations in sectors such as automotive, energy, and heavy industry. Peter has over 30 years of experience working in data, analytics, and technology across Europe. Prior to his acquisition by Cisco, he was a director at the IoT analytics platform company ParStream. Peter led ParStream's expansion into France and managed strategic partnerships in the region while leading the TM Forum's Big Data Analytics Working Group. All speakers will be available after the session, so please submit your questions into a section box in your control panel. I think we're ready now, so it's over to you, John.
Hello and welcome to InVMA's Hidden Factory webinar series. My name is John Hill. I'm the Chief Operating Officer of InVMA. And before I introduce you to our guest speaker today, I'd like to just explain to you a little bit about InVMA and who we are, the background to the webinar series, and also what you can expect to get value from the series as you look through and probably look at the other webinars that we have on offer. So first of all, about InVMA. Our purpose is to connect the physical and digital worlds to transform industry. And we do this by using technology, solving problems, and driving change. What makes us unique is that we have a deep sector expertise and track record in the industrial market. We have an end-to-end industrial transformation capability from strategy consultancy through to control systems integration. We have an extensive ecosystem of partners. They include PTC with their ThingWorx and Vuforia Studio, Microsoft Azure, ARM for connectivity, Dell for gateways and hardware, and we also have our service partners of DMS and Senseye. The other thing that makes us unique is our flexible products and services. We have our Asset Minder product, which enables you to rapidly get to value in your digital transformation or smart factory implementation. And our services range from a simple discovery workshop to expose you to the new technologies that may impact your business, through to a strategy workshop with your senior leadership team to identify where the best bets are to place with the new digital technologies, a design and implementation workshop, which looks at how and what's the best ways of implementing in your specific situation, followed by our more traditional application development and system integration services. And of course, once you have done the implementation, our support package and service level agreements to help maintain the savings and investments that you've made. Why did we decide on raising and starting this webinar series? Well, bluntly, it's because digital transformation is happening now. Recent study by PwC showed that 90% of industrial companies are investing in digital factories. 70% of companies consider digital manufacturing at the top of their operation strategy agenda, according to McKinsey. And indeed, in the United States, the National Association of Manufacturers have made the statement that industrial companies need to capitalize on digital technologies to defend and advance their competitive advantage. Indeed, the World Economic Forum have found that those companies, the lighthouse implementations, as they call them, yield a huge impact. And they've reported double-digit KPI improvement in areas from factory output increase to productivity to OEE to product cost, time to market reduction. And indeed, the Standard & Poor's have noted that failure to act and make digital implementations over the next 10 years, half of the people in the Standard & Poor's 500 firms will be displaced. Most companies fail to move to this stage of scale and capture value at scale. And McKinsey in 2018 identified that in large factories, there were up to 8 digital transformation related pilots running in each one of those factories. But only 25% of those succeeded. 75% of those failed to go on to deliver any continuing value. And that's why we set up the webinar series. What we're trying to do is, through our demonstrations of maybe the technology and our approaches, but more importantly, presentations from our partners and our customers who are going through this process or have delivered on these processes right now, will prove valuable to our other potential customers and current customers. So thank you very much for listening to this. And now I'm going to introduce our speaker.
Hello, I'm Andy Gailey, owner and founder of Uptime Consultant Ltd. It's a consultancy based here in the UK. And today I'm going to share with you a story about change, and in that change, the importance of people. So if we just imagine a process or a factory or a production line where we know everything that's going on with our assets all of the time, it sounds a bit of a stretch and a bit like science fiction, but I think with the technology we've got at the moment and with people with the right mindset, we can now realize that kind of future looking plant. So Apple computers were not a failure as a business, but they did sell really close to bankruptcy. And after a 12-year break, Steve Jobs returned to Apple in 1997 after that break. And it took another 4 years for them to come up with a revolutionary piece of equipment called the iPod, which aimed to put 1,000 songs in your pocket. And that led to the first smartphone. The smartphone's changed everything. It's the device that now people refer to before smartphones and after smartphones. So the ecosystem that's built up around them has been remarkable. The important shift that Apple made was that enter into the music business, really. They transformed their business into the music business rather than PC business. Microsoft were already beating them at PCs, so Apple came up with this idea, and then they shared it across the platforms that Windows used and Apple used. So it's a pretty smart move. Nobody actually saw this coming. I believe it's probably the most significant business change they made at Apple, and it's something that Steve Jobs did very rarely. He rarely moved off, traveling off a planned course of action. So change, we can see, is a very important concept, and it's one that we should adopt not just in life but in our business practices and learn to embrace. Everywhere we look, especially everywhere I go, there's a desire for increased efficiency by achieving more out of our asset group. Some refer to it as sweating the asset, and this is fine until things start to fail and break down, and then we get in trouble. And unfortunately, the enablers of change that are involved within the business or the technology that's available, they're often missing because they're too caught up in the everyday. They're too caught up in, obviously, producing their automotive vehicles or their snack food or whatever other commodity they produce. And this leads to reactive behaviors. People are forever chasing the time that they've lost. And this infographic here actually explains a journey that took about 5 years from heavy double figures unplanned downtime to single figures. And it was a transformation of a business, basically from out of control to a planned, predictive and proactive future. So one of the enablers for this operational uptime was maintenance. Many in operations don't realise this, And over time, the people that carry out these maintenance practices become reactive in their outlook and in what they do at work. So I've seen engineering departments and maintenance departments actually with signs up that say this is the reactive team. And the talk is all about getting things fixed quickly, how they can recover the reaction. They talk about how they're going to fix something again. They've already experienced it before. And this has to change. This mindset has to change, and the way we do things has to change. It can stay the same, but then again, what happens when your competitor changes and you don't? Then obviously you're at a loss. The good news is that these changes we're looking for are now possible. We actually have the technology to start these journeys to the smart factory we visited at the start of this piece. Just 10 years ago, as a practitioner in a large business, I always pondered what I could do if I could capture 500 readings rather than the 100 I was constrained to by time being that finite resource. Back then, obviously, the answers were missing because we didn't have the connectivity that we have now today. There was no such things really as smart sensors, and the cloud services were more or less non-existent. So now everything has changed. We have these the technological solutions. So the big risks today aren't particularly the technology and how to apply it. It's the people. It's the people-centric part of it. It's people like me and you are listening that will make this change. So I reach out and I attend as many of these conferences to do with Industry 4 or the Industrial Internet of Things, and I talk to like-minded people, and we all come to the same kind of conclusion at the end of the day, that it's the lack of people and the applicable skills to take this journey forward. Because at the end of the day, it's we who are the change merchants. The technology will not apply itself. That hasn't happened yet. So the availability of the right people with change skills, people that I think about as being the iPod thinker rather than the PC thinker, that's what's going to be really important. The other thing that's going to be important is we should think about how demographics are changing the way we can work and people are involved in industry. This is already causing massive disruptions across the globe, and Japan is right ahead of this disruption with its aging population. And this has accelerated the adoption of robotics, especially in Japan, and a lot of their robotics is now pointed towards that aging population, either to keep them company or to look after them. So this graph actually looks at what the population of Japan looked like back in 1950. Male are to the left of this pyramid and female are to the right. As you can see, it was a very pyramid-shaped diagram with the cohort at the top there above 60 is quite small, supported by all these younger people in the demographic. Obviously, this has changed, and in 2015, it looked like this. So now we've got these people that were in 1950 have now moved up this graph, and we're starting to get a top-heavy scenario. They think that by 2050, this is what Japan will look like. So we've inverted the pyramid now, and we've got all of these people of a fewer people of working age supporting the people outside of the working population. So China is no different. They have what they call the 4-2-1 syndrome, where there's actually one working person supporting their parents and two sets of grandparents. The Western economies aren't immune to this. My age group is at the age of the baby boomers, so we're leaving the workforce, and the cohort that's following us is a lot smaller. There just aren't the people there. So something has to fill this people gap, and I believe that the technological solutions we've got now and will happen in the next 5 to 10 years are going to help towards that. So when I'm in businesses and I explain this to them, They're obviously they're stuck in their traditional cycle of break and fix, and forever reinventing the wheel, and there's a shortage of labour. I put something like this in front of them. I explain that in traditional factories, 10 or 15 years ago, we had those same processes. They were all spreadsheet or paper based. And the difference is now all of those processes can be automated. They can be scaled up to cover more assets in those shorter time frames with less amount of people required. The three finiters at the bottom, because this is something I constantly talk about across all the things I do, that they are time, money, and people or resources. These three finites drive not just what we do in business, but what we do in our private lives. So there's only 24 hours in a day. We've only got so much money. There's only 70 years in a lifetime. So people are very important, and we're not going to see any more of them, because if our budget is restricted, we can't go and get any more people. So the gap of less people is an important one, because we want to maintain our uptime. As an aside from the webinar at the moment, the reason why we're taking this webinar is because we had to cancel an event last Friday because of the outbreak of COVID-19, which is just in a short week has become a global event. And I believe it's become even more apparent we need to pursue a different way of working, not just in operations, but in the way we work, restricting our travel, and being able to leverage these new technologies and tools. So I've been personally advocating the use of platforms like Zoom and virtual learning for the past couple of years. And last year I launched Uptime Consultant Academy that takes some training online and is given away for free to people wanting to start out on their reliability journey. So in this diagram, back to the diagram, we see a virtuous cycle of how a real ecosystem works. So this is actually happening now in a facility. I'm sure Peter Livaudais from Senseye following will elaborate upon that. But what happens is now we've still got the people within the plant, but they have a dashboard, they have assets, they have a local historian, and this information is transported through the cloud to the back end people, the machine learning algorithm people and artificial intelligence specialists, who then feed back into the system, and it's a continuous cycle of learning. So utilizing this type of scenario, we've made more time. We can't buy time, but we've made more time. We can now plan what to do next, when we need to plan it in, and more importantly, get information about how to avoid it in the future. So coming to the end, the last 5 years that I've been running Uptime Consultant, it's been very interesting observing the developments in Industry 4. It's slowly taking shape with early adopters. Myself and Nissan work together along with Senseye, and they've stolen a march basically on the large companies. Companies are very conservative. They want long lead times when they're investing. There's also underlying financial issues that have been obviously apparent over the last 10 years especially, that has not allowed Industry 4 to accelerate at the pace we would like. So closing, my last thought is I never thought that a global pandemic would provide the impetus for adoption. But it may be the output of these times that we're living in today that will shape how we work tomorrow. I hope you enjoyed the short presentation. We've jointly written a white paper with InVMA, so they'll share that with you. Please feel free to reach out to me at Uptime Consultant, and maybe we can get a Zoom call sometime in the future and discuss your requirements. So thanks very much for attending, and I'll hand over to Peter.
Thank you, Andy. We will, of course, share the white paper and the recording of this webinar after the session. Now it's over to Peter.
We reached the third and final presentation in today's installment of this webinar series. As can be seen worldwide, what dictates our reaction to challenges is behavior. The two prior sessions by John and Andy were very much focused on attitude, the human aspect of production. And as Andy said, technology is here, and I'm here to talk about such technology. In fact, the aptitude, and that aptitude is scalable predictive maintenance. My name is Peter Livaudais. I represent Senseye, a predictive maintenance SaaS, and a partner of both InVMA and Uptime. Briefly, I will present Senseye and explain what's different about it. And then, not to be fully pro domo, I will present some key success factors for any condition-based maintenance or predictive maintenance project. And then I'll conclude with some examples. So, let me introduce you to Senseye. Senseye is a predictive maintenance technology that is characterized by three things. First, it is automated. That is to say, it uses machine learning to predict industrial equipment failure. Second, it is a maintenance team app. That is to say, not a data platform. That is to say, just like a search engine, something that gets better the more you use it. And because of these two first properties, there comes the third, which is to say it is scalable. And you can scale out of what John has presented as the pilot purgatory. So if Senseye leverages the industrial Internet of Things for the detection, diagnostics, and processing of machine failures. Otherwise said, it is a cloud service. And so let's look at why it is important. Downtime is a huge element of the hidden factory. Some estimate that the amount that downtime costs are underestimated by a total of 300%. And shortly put, maintenance strategies today are either too much or too little. Too little, when they are reactive and running on a fail and fix strategy that Andy described. So running after costly fails. And this is one of the reasons that maintenance costs and downtime can cost for upwards of 24% of total production costs. So it is a very big issue. And so let's look at those three aspects of Senseye. First, Senseye is smart because it's a self-learning system. It will take industrial data from equipment, mix that with maintenance data, production data, and user feedback in order to create overall asset health evaluation and to be able to calculate based on trends and alerts that it raises the remaining useful life of a piece of equipment. So first of all, it's smart. Second of all, as I said, as an app, it's simple. It's for end users. This is for maintenance staff, managers, technicians, machines experts, and it's easy to use. The training of the machine training it can be done. It can be as short as 2 weeks, and the user training is usually as short as 1 to 2 hours. So it is a user enablement tool to help maintenance teams get their maintenance under control. So it's smart, it's simple, and because of that, it is scalable. And that scaling can be vertical or that can be horizontal. That is to say, this can scale across multiple assets of a common type, or it can scale across multiple assets of different types. And there is no adherence to any particular form of asset or industry. So that's a brief introduction to Senseye. And now I would like to concentrate on some success factors for any predictive maintenance project. And the first of these three rules is look for ROI. If you have a project with ROI, then you're looking at a project that will scale. If you're looking at a project that doesn't have ROI, then you're probably with an IO Industry 4.0 experimentation that will not scale, and therefore your project will not be a success. You will remain in what has been described as your pilot purgatory. And this is a typical example in the automobile industry of how you would calculate the ROI. You look at the cost of an hour of unplanned downtime. You figure out how many hours of that unplanned downtime you have during the year. What would be the consequence if that was reduced by 50%, and that would give you your savings. And there you would be able to figure out your ROI. In this case, an ROI superior to 10x. And these are the kinds of projects that you need to look for. So ROI and economic viability and reality of the project is the first cause of success or failure of a project. The second is data quality versus quantity. You do not want to have raw process data. You do want to have a high signal to noise data. One of the best examples of where quality preempts quantity is if you have people in a room. If everybody talks at the same time, nobody will understand what is going on. So there has been a myth, however, that has been created in the market by platform suppliers and in big data, that is, with enough data, then you will have the answers to all your questions. So quality is better than, so quantity is better than, is the answer. So that surely is a second success factor, which is very important. Quality in, quality out. If you quantity in, quantity out, and you will have alarms for all your maintenance teams, and it will not serve the cause. The third critical success factor is that this is not something you install and forget. This predictive maintenance is a iterative operational process. This is something that this is a journey that you start. And just as with OEE, when you reach a certain level, you want to go to the next. So you should know that when you're starting with a predictive maintenance and condition-based maintenance, you're actually changing culture, you're changing behavior, and this is the third critical success factor in predictive maintenance projects. So and you can conduct these. We can conduct these in micro steps of weeks and months. Now, to close out this short presentation, some examples. Our showcase example number one is Nissan. This is a project that started with a drop lifter in Sunderland, so in the UK. This is a drop lifter is an elevator that will bring the car up or down from a certain level, so you can work at the floor level or you can work underneath. Of course, this is critical equipment for a car factory when this stops production. This equipment was built when cars were small and light, and now they're hauling around cars that are heavy SUVs. So we went in and we completed this project. Suffice to move fast forward. Now that we're deploying in projects all over in factories all over the world, where results can achieve in factories over 20x ROI, reducing downtime by 50%. A second use case is Alcoa. We were compared with many a predictive maintenance solution. Here, this was a plant where we worked, and now we're deploying to plants all over the world. And the ROI in this case was under 3 months, also with a 20% reduction in maintenance costs. And I'd like to finish with a really significant use case for us. We started in a factory in Schneider Electric on what you see in the photograph, which is a winding machine. This is critical equipment for Schneider Electric. And now we are deploying in factories all over the world, from Asia to the Americas. And there was a 7-point increase in OEE on that particular equipment. But Schneider is much more than a client for us. They're also a partner. Schneider is distributing our service, and our teams are capable of conducting predictive maintenance projects with our technology. They're also integrating our technology into other products that they have, and we're working with them with their innovation team. So this is for us a very strategic relationship. So there, what I've done is I've given you some example of Senseye and what makes it different. It's automated, it's user enablement, and it's scalable. I've given you some critical success factors for projects that, as I said, ROI, data quality, and iterative process. And now with these 3 examples, I hope you've gotten an idea of the types of things you can do with predictive maintenance. And so with that, I complete the presentation, and I will hand it over for questions and answers, and hope that you have some. Thank you.
Andy, in the deployment, I know you're involved in Nissan. What were the sort of the key learns that you had, or indeed that Nissan had, do you think, in the terms of delivery? And what would your advice be to other people considering a journey to predictive maintenance using machine learning?
The really good thing about Nissan, and it's why I enjoy going there, although it's a 400-mile round trip, is the people. The people are so receptive. And when I first went in there, they introduced me to the Senseye dashboard. I went in there to deliver days training on an introduction to predictive and proactive maintenance. And the reason for that was that they got ahead of the curve with the Senseye platform, and that then led to these reactive mindset engineers having to think about how do they think differently. So there was definitely a human aspect that they struggled with, but it didn't. It only takes a day, to be honest, especially at Nissan with the people. So there's always, when you speak to workforces, there's always a suspicion that this is going to take away their jobs, and it doesn't. What it does, it upskills them, because, and you see it when I revisited there about 6 months later, they were having less reactive periods where they had to react to machines, and they got a greater understanding of the population of their assets. So you've got to imagine the body shop there at Nissan has 2,000 robots underneath one roof. Half of those are manipulating and half are welding, and you've got 6 people to look after them. So if these guys go in at the start of a shift and they haven't got a clue what they're going to look at next, it takes you 10 minutes to walk from one side of the factory to the other. So they were overwhelmed just in transport time. As it was, within a few months, couple of months of having Senseye and using the platform and putting information in and getting feedback, they were now getting to the 2 or 3% of the population that were the bad actors. They didn't have to look at 2,000 machines anymore. They were still reaping the information from those machines, because they will become the bad actors of the future. So my role there was to coach, really, the human change from reaction to proactive and predictive behavior.
Okay, it's interesting. Actually, we just had a couple of questions that have come through as well. So, Paul, if I could ask you, probably linked to this actually, Andy, is will technology replace my entire workforce?
I'll give a short answer to that. Of course, Andy will have lots to say. One of our clients qualifies this as blue collar digitalization. So they say, I've digitalized my white collar, my engineering, but my blue collar, they don't have the support they need. It is in some countries there. It's estimated that there are several tens of thousands of maintenance engineers missing. And as Andy said, there's a generation of experience that's retiring. So and a generation that generation experienced the digitalization of the factory. So actually, it's an enablement, and what it does not replace the workforce, but it sure makes them more productive, gives them more control, and lets them address a situation where they're already stretched too thin. And this is what it's because there are so many people that are lacking in the workforce, that you're getting new people that are in maintenance operations, so operators and people that weren't previously there. So it's really a way to, I would say, a way to regain control and enable that the maintenance teams.
Okay, Andy, have you got anything to add to this?
Yeah, this is a question I thought would come up anyway. And yeah, all new technologies displace people or jobs. And what happens is we invent new jobs. So I remember probably 15 years ago going into a bank and it being full of bank tellers. That's no longer the case. I think I'm down to one branch near where I live. And it's the same in factories. There aren't the people there, to be honest. The guys at Nissan, 2 of those were what I'd call trainee technicians. They'd come from an unskilled background and were skilling up. And the people just aren't there, I'm afraid. So one of the things we have to think about is who's going to fill this gap. It's a real struggle at the moment out in industry to find a mechanical or an electrical engineer that has a predictive and proactive background. All of the people that are using old techniques of waiting for things to break, they're running their engineering stuff into the ground, basically. You see the frustration on people's faces when you go in and look at so I go and fault find sometimes one piece of equipment, and you can see the frustration in people when they've revisited this equipment, for years probably, and still not got to the bottom of it.
And Andy, on that, and Peter, have you discovered any additional benefits from implementing the predictive maintenance systems that you weren't expecting?
Well, from a predictive point of view, so when I was a practitioner, I was asked to invent a predictive maintenance strategy. And the first thing, I had a really good manager, and the first thing he said to me was, you must report every month the ROI. So I'm always, although we're looking at prediction and condition monitoring and technology and smart sensors and all the things that engineers like to play with, at the end of the day, we've got to remember we're about whatever we're manufacturing. In my case at PepsiCo, it was pence per kilo. Pence per kilo was king. It will be SCUs at other places. It will be the amount of automobiles an hour in other factories. So these are tools. We've got to understand that condition monitoring and predictive maintenance and all maintenance practices are tools to enable reliability that's inherent within our assets. So when engineers who are in a reactive phase look at prediction and they say, well, I don't like this because this might put me out of reactive work. I said, well, that's the point of it, to be honest, is to be out of reactive work so that you get to do what you were trained to do in the first place, and that's be an engineer. And if you look at the description of maintenance, there's nothing in maintenance that says fixing anything. It's about maintaining the state of the asset in the condition you bought it for. There's loads of stuff comes out of prediction. Waste streams, sustainability, power usage, water use, labour usage, even things like people's demeanour changes. So it's amazing to see transformation in people when they're in control.
Okay, interesting. Peter, have you got anything to add to that in terms of things that we're not
expecting? I would like to add something. Not necessarily that I wasn't expecting, but I think there's an underlying aspect to this, which is that there's more and more competition for production, and connecting objects like this, and managing things from the point of view of a fleet, rather than managing things from a point of view of a product. So managing it from what Andy was just referring to as a service. That means competition becomes competition on a servitization level, and be it for machine builders or be it for plant operators. The fact of being able to take this approach is actually it's an entry barrier, and it's a competitive factor for gaining access to production. We're seeing producers that need that in industries such as utilities that are obliged to show to earn their contracts to operate infrastructure, that are obliged to show that they have adopted certain methods and certain best practices. So this subject can become can go pretty far. It goes to revenue.
Okay, it's interesting. And guys, another question is there such a thing as over maintenance?
Yes,
well, certainly. That's what when I say too much or too little. Preventive maintenance, that is to say scheduled maintenance, but Andy will be much more better to reply to this than me, so I'll be super short. But essentially, run to failure is roughly up to 10 times more expensive than condition-based, and preventive is maybe 2 to 3 times more expensive. Andy, you're certainly better to answer that. I'm sorry to continue.
I don't particularly like the term run to failure. I don't like terms with failure in them, but if people use their assets until they're no longer available, sometimes that's a correct strategy if you've got redundancy built in. If we should be looking at the risks and the consequences of the asset being out of use. So for me, prediction is a tool within your maintenance and reliability toolkit, and you start with saying, what happens if? So you do a criticality study. I do criticality studies all the time. You do the criticality study. You go, what happens if? So I don't change the oil in my car every week. That would be over maintenance. I take advice from the manufacturer, says every 2 years. I don't over maintain anything in my vehicle, my car, and we don't, because reliability is pretty good and pretty well built in. But we mitigate that through insurance, through recovery, and maybe, if you've got a maintenance insurance. So within the factory and within the production, there are different ways depending. So not one fit. It doesn't suit all, one fit. So within maintenance strategy, there will be parts of plant that will be let's run it until it breaks. And to be honest, within asset groups, I'm a very big believer in Pareto analysis. Within asset groups, if you can identify the 20% of all the assets that give you 80% of all your problems, you're winning. So I would say if anybody's going to a proof of concept with a predictive online strategy, you've got to identify that 1 in 5. So you've got to identify that top 20% of your assets that takes up 80% of your maintenance budget. And if you target your resources at that, then eventually you can trickle down amongst the rest. The choices 10, 15 years ago were you only looked at your critical stuff. And even then, you were time constrained. So within food industry, I only really looked top line at extruders and platforms that would cost the whole line to go down. But we wouldn't look at auxiliary pumps, and we wouldn't particularly look at seasoning units. But now, because of the visibility, we can look at everything, and we can look at it without actually physically looking at it. So that's the problem is with traditional predictive and condition monitoring, you have to have a human look at it. With these systems, this is why I spoke to Senseye, we had some talks, and I think it does what it says on the tin. So it automates thousands of outputs from machinery, and you can go global. That's the thing that we were always constrained to the factory walls. So with this, if you think about it, if you were a big business and you've got multiple locations around the world, why wouldn't you want to benchmark one machine against the next? So within the Nissan group, I would think now they've got FANUC robots in Sunderland, the same FANUC robot in North America, the same one in France, and they can now look at populations of assets. There's so many branches to it that it's going to spread. That it's exciting times, I think.
Agreed. Okay, so has anyone got any more questions before we I turn to Agatha to close the webinar? It doesn't appear to be. So all it is left for me to say is thank you very much, gents, for your insights and your expertise, and really appreciate it. Thank you.